Hello, everybody. Thanks for coming along. My name's Peter Elger. I work with nearForm, and I'm here to talk to you today about some of our experiences in developing microservice-based systems and working with microservice architectures, some of the challenges that we faced in that, and some tooling that we've developed to help us in those endeavors. So first off, I guess, to say microservices, everybody's probably come across the term now, has an idea of what microservices are, maybe even developing in that type of environment, that type of architecture. Not a new concept. The idea of small components that fit together well has been around for a long time. The idea of having small components that are easily understood, easy to reason about in isolation is generally a good one. Supporting kind of a rapid iterative deployment model. And it's an architectural style that's particularly suited to Node. When we first started off building systems in Node way back in 2011, right at the start, around 0.40, we found that the way that Node has its module system, the way that it's put together, naturally drove us to write microservice-based systems. So the first system we actually put into production was one where we had a number of small processes that were all cooperating with each other to deliver the system. Now, at the time, we didn't know that was a microservice system. The term had yet to be coined. But it was just interesting to observe, as the rising popularity of that architecture has taken place, how it suits very well the kind of Node ethos. So that's all awesome, OK? But there are challenges, right? Hal. If anyone here has got experience of developing microservice systems, you know that it can be difficult to run these systems in development. It's fine about all of the things, the benefits that they give you in production, but in development, it can be hard to run all of these processes. How do you run an integration on your local system? So there's a number of trade-offs there, right? Microservices give you small units of code. They're very easy to reason about in isolation. They're easy to test, and they support that rapid deployment model. Whereas monoliths, you typically have a large amount of code. We see this all the time in legacy platforms, where you would have like quite a large class hierarchy. That can be quite difficult to reason about, and the code becomes brittle over time. The code is highly coupled, and it gives you risky deployments. However, in development, if you want to run your microservices, you've got to deal with multiple processes. You've got a lot of processes that you've got to run at one time, even if you're running just a subset of the system. So it's trickier to apply our standard kind of tooling and debugging approaches to microservices. Whereas with monoliths, of course, it's easier to run a system in development. It's typically a single process, and a lot of tooling is oriented towards doing that. So what are our options? What can we do about this? Well, one approach is just to develop our services in isolation. They're easy to reason about. They're easy to unit test. We can get good code coverage. And then let's maybe have some kind of staging system or even production, push our services onto that staging system and do the integration there, so have one integration point. And that's an approach that can work. Another approach is to develop some custom scripts. So, and we've done this on a number of occasions where we have a project, we've got a bunch of services we need to run, we want to do an integration test, or we want to test part of the system operating on our local development machines. So we write a bunch of scripts, and those spin up the processes on various ports and allow parts of the system to operate and allow us to run debugs or whatever it is we want to do as we're developing the system. It can work well. If there's overhead, you have to maintain a whole bunch of scripts as well. And you also need to make sure that your machines have the same infrastructure on them, the same databases, caches, whatever it is you're going to use. Another approach, of course, is to use containers. So obviously, Docker has become incredibly popular and is a very nice fit. It fits well with the whole microservice paradigm, where you have a single process running in a single container. You've got these units that you can deploy. And you can use those in development as well, particularly using tools like Docker Compose, which allow you to specify how your services fit together in a single configuration file, allow you to spin all of those processes up, managed by Docker, and run your system. However, it does come with a few issues, primarily that the container build cycle can slow you down a little. So if you have to go build a new layer or build a new container every time you make a change to your service and then spin that up, that can be slow and a little bit frustrating. Also, there are some environmental differences when you're trying to run in this mode. If you're using Compose or Docker on a Mac or on a Windows machine, you'll know that there's actually a VM that's booted up under the hood, and your containers run on that. So you're now dealing with differences between running on localhost and having another IP address to talk to. And also setting up debugging environments can be a little challenging. So given all of that, what we've done is we've taken all of the knowledge that we built up on these projects to create a bit of open source tooling to help us develop microservices more efficiently. The code's up on GitHub there, go check it out. And we had really a couple of goals when we were building Fuge. One was to give us a tool that generated a microservice scaffolding for us. So in order to get a project booted up, if we're doing greenfield development, then we can just boot up a front end and a couple of services and have that run straight away. So we've got a scaffold we can then go fill in. So we're kind of establishing through a tool best practices as we see it. That might not be your best practice, but it's the way that we're doing it at the moment. And the second thing was to provide a runtime environment for microservices to allow us to do rapid development and reduce the friction between containers and running processes. So what we want to be able to do is we want to be able to run processes, debug them, make changes to them, have those changes be reflected very quickly, but also take advantage of container technology to run our infrastructure, databases, and so on. So I'm going to demonstrate that to you in a moment. Just a quick word on the systems that we kind of develop. Usually, we use a combination of Happy and Seneca when we're developing microservice systems. Both awesome projects. If you don't know them, you should. Go check them out. We use Happy for the kind of front-end API layers, and then Seneca for microservice construction. And Seneca allows you to build like a pattern language for your microservices. So check it out on GitHub, and you'll get a little more detail on it. So this is the type of system I'm talking about. We have usually a route into the system, so some API layer, and then some form of service discovery or overlay network to allow us to connect into our services, and then a bunch of services that might be kind of direct response, so they're HTTP-based, and maybe some more asynchronous services that are running connected over a bus, maybe RabbitMQ, ZeroMQ, or something like that. The services themselves are taking care of their own world of data, and then potentially consuming legacy APIs or external APIs. It's fairly standard stuff, right? So, code time. What I'm going to do now is use Fuge to generate a system of that type. So let me just... Okay, so I'm in an empty folder here. So I'm just going to run Fuge generate system. And that's just asking me what transponder I want to use, so I'm going to just take the default, which is HTTP. Under the hood now, what that's doing is it's spinning up a number of yeoman generators to put a system in place for me. So I can now, if I just flip back, I'll show you this. We'll leave that running just for a second. This is what I'm going to get at the end of that command running. It's going to give me a front end and a couple of services and a proxy layer. I'll talk a little bit more about that in a moment. So it's going to create a few directories for me. It's going to create a Fuge folder, which has some control files in it, a couple of services, and then a site directory, which is where my front-end API layer lives. In each of those, it's going to give me a Docker file, and then it's going to hook those together with a Docker Compose file. So we're using the standard Docker syntax, but Fuge is introspecting those to run the system and allow us to run processes, which we can debug in the standard way, or containers, or a mixture of both. And it's allowing us to run that mixture of containers and processes that gives us a rapid development environment. So we should now be able to execute our generated system. So let me just flip back here. OK, great. So we've generated the system. Thank you, Conference Wi-Fi, for that. So we can start the system up with Fuge shell. OK. So Fuge has now introspected our compose file. It's looked at the Docker files, and it's figured out that it's got to run 2 services in a front end. So now I can start those up. And my system's up and running. So I've generated a microservice system, 2 services up and running, and now we can go and test that out. If we just go to Chrome here. That, and if I hit action 2, you can see that what's happening there is that's calling into Happy, making a call out to one of my microservices in Seneca, and sending a result back. So we've got a skeletal system that we can now go and work with. So let me just pop back here. And you can see that, you can see that Fuge now has those processes up and running. It's tailing the logs on those processes, and it's watching them for changes as well. So let me just exit that. That's great. So next, I'm going to add another service into the system. So I'm going to use Fuge to generate a second service. And when I do that, my system's going to look like that, exactly as before, but with an additional service that I can now go and edit, make changes to, and do something useful. Okay? So let's pop back here, and I will do a Fuge. I'll give it a name. Okay, and again, it's running some Yeoman generators and creating another service that I can now hook in. It's up and running. So if I run my shell again, if I could type, you'll see that there's now another service available, and I can start that up as before, and I've got an additional service now running. OK, so that's fine. It's not that interesting because it's a skeleton. So let's go and let's do something a little more interesting with it. Let's add some infrastructure. So we're going to add in a MongoDB database container. And to do that, I've already pulled that container from Docker Hub using the Docker pull command. We're going to make an edit to our compose file to bring that into the system. And then we're going to add a bit of code into one of our services to consume that. So let me jump out and do that. So in actual fact, here's one that I created earlier. And here now you'll see that in my compose file, I've now got a Mongo container linked in with the image tag, my 3 services, and my front end. And if we just go and have a quick look under my service 1 code, you'll see that I've added in to my Seneca handler here some code to consume, to talk to Mongo. It's not doing anything that interesting. It's just writing a record in every time the service gets called, and it's returning the count plus an offset. And again, that's being called through this API layer here. So if you look at the code in services, you'll see that all that's going on here is I'm taking a happy route. So I'm coming in through a happy route, and then I'm converting that to a Seneca action pattern, which is then executing the service. So let me just go ahead and run that system now. So again, Fuge sees my additional containers. But now what it's going to do, you'll see that it's got Mongo listed there as type Docker, and the others as type process. So what Fuge is going to do now is it's going to run Mongo as a container using the Docker VM that's on this system. And then it's going to proxy those connections across. So if you look at the proxy statements there, you'll see that it's proxying the Mongo port 27017 across to a different IP address to the others. And that's because the 192.168.99.100 is the address of the Docker VM on my machine. So if I just start that up. you'll see that all of those processes are now up and running. That's actually a little bit noisy, so what I'm going to do is I'm just going to untail those, and then I'm going to tail service 1. By default, Fuge will tail all of the processes, so you'll see a whole bunch of logs coming out. So we can just quieten that down by telling it not to tail so much. So now that system's up and running, if I flip back over to my browser, I can execute those commands. So action 2 hasn't changed at all, but when I hit action 1, you'll see the count being reflected, and as I hit that again and again, you'll see the count coming up. So if I now flip back here, you'll see that the logs are a little bit quieter because I've just quietened them down. We don't want to see all that spew of logs coming out. So now what I'm going to do is I am going to make a change to my service. So if I flip in here to service 1 and into my code that's calling Mongo, I might just change that count that's being reflected there. I'll get rid of the offset. And you'll notice now that what's happened is that because Fuge is watching that process, it's restarted service 1. So there's been a change to the service. Service 1 has been restarted by Fuge. So my system is now completely in sync with the changes that I've made, and also able to talk and proxy through to my Mongo container that's running in the VM. So we'll just give that a test. If I now come over here and hit action 2, no change, action 1. Okay, now my count is minus the offset. Now, another thing that we wanted to do with Fuge is make debugging a little bit easier. So we've got a little experimental command in here to help us with debugging. So if I just PS, you'll see that service 1 is running, all the services are up. So I'm going to stop service 1 now. Can you pull up your terminal? Sorry? Oh, I'm sorry, guys. Yeah, absolutely. Bear with me. Okay, there we go. So I've just stopped service 1. And if I run a PS, you'll see that everything's running, but service 1 is currently down. So now I'm going to debug service 1. And when I do that, Fuge has now launched a node debug for me. And I'll just flip it over here so you can see it. So if I now go back and hit my root here, hit my action 1 handler, what we should see in the other Chrome window. Okay, so now I've hit a breakpoint in my service. I can do whatever debugging I want and continue on. I hit it a couple of times, so I hit the breakpoint twice. So the point of all of this is to have a tool that allows us to develop these microservice systems and give us a bunch of convenience methods to start and stop services, control them all without having shell HAL, and allow us to interoperate between containers and processes. So that's great if you're doing. Sorry, what I'm going to do now is just stop the system. And exit out of there, okay. So that's great if you're developing greenfield, but we also want to be able to retrofit this to existing systems, because a lot of the times we come up against systems that are partway developed or already have a bunch of microservices in them. As an example, I've taken a system that we use for training purposes called NodeZoo. And NodeZoo has a few more bits and pieces in it, okay? What NodeZoo does, actually, it's interesting. You can have a look at nodezoo.com for a live example, is it does kind of PageRank on node modules. So it goes off and it has a bunch of services that go and look at GitHub, NPM, and then index those and do a bit of computation and return a result. So in order to retrofit Fuge onto Node.js to allow us to run it without having multiple shell processes everywhere, all we need to do is modify our compose.yaml or create a compose file for it that references each of the components. And what I'm going to do in this instance is run the system using a mixture of Docker Compose and Fuge. And I'm getting close to time, so I'm just going to go and do this very quickly. So now if I flip up. So here I'm going to use Docker Compose now to run my infrastructure containers. Those are up and running, and then I'm going to run my Fuge shell here. And now you can see that Fuge understands that it's not managing those Docker containers, but it is managing the processes. You'll see that it's proxying across to Redis, Elasticsearch, Influx, and Beanstalk-D. So I can now start all of those processes up. And now I've got my mixture of containers being run on the one hand, which gives me the convenience of downloading and running containers from Docker, along with the ability to run my processes, run debug, and manage them in a nice, clean environment. And I'll just check that Node.js is up and running. Flip into the other. So it should be up and running on localhost. There we go. There we go. Just hit that. So it's going off and indexing GitHub and NPM and bringing in information about Fuge this time. So, so just to wrap up then, in summary, developing microservices is a challenge. Tooling can help. Fuge is one of the tools that we've developed. We're using it now on a couple of projects. It's all open source, so we'd love you to go take a look at it. If you're working in microservices or in a microservice environment, please check it out. Any comments or pull requests even would be much appreciated. Just one big shout out to the contributors to Fuge, Matteo, Dave Clement, Dean, and Murcha. And thank you very much. We have time for questions? I'm not sure. Take one question. Sure. Was it actually running Docker containers, or was it including something else? No, it was running a mixture of containers and processes. So it was Fuge will run the containers, but also you can use Compose to run those containers outside of Fuge, and it will then proxy across. So the idea is just to remove the friction. Yeah. Sure. Depends on the system, right? So it could be as simple as DNS or a well-known ports, or something like console or something a bit more complicated. Depends on the system type. Yeah, sure.